a project which represents a cost-sharing program by the Alyeska Pipeline Service Company and the state of Alaska. In telling the story, one could dwell at length on the pipe alone. It is of steel, specially alloyed and fabricated with a yield strength in the order of 60,000 to 70,000 pounds per square inch. Wall thickness of the 48-inch pipe ranges to more than 1/2 inch. This is the pipe storage yard at Fairbanks, one of 3 sites employed to prepare the 40-foot sections for field installation. The other locations at Valdez and Prudhoe Bay. Here, the pipe is subjected to an individual heat cleaning process to remove a protective coating applied earlier. Then, 2 40-foot sections welded together. After rigid inspection, 3 80-foot sections are loaded on special carriers, destined for one of 56 sites along the construction corridor. The pipeline itself is built in 3 different ways, with a work pad the full length of the corridor, and never has a construction surface been employed with such prime consideration for the environment. Consider for a moment, without a substantial surface, construction would have been limited to that period when the ground is frozen. After thawing, of course, the fragile tundra is very vulnerable to even the smallest vehicles. Observing strict guidelines, the work pad is built, capable of supporting the heaviest equipment, and at the same time, neighboring vegetation is preserved. It starts here, on the treeless north slope. As you may know, the oil emerges from the 2-mile-deep wells hot, about 140 degrees, and will be kept warm by friction throughout the length of the pipeline. Through the Adagon Pass in the Brooks Range, Isabel Pass in the Alaska Range, and Thompson Pass in the Chugach Mountains. Because of these ever-changing terrain features, extreme temperature range, and environmental complexities, the most sophisticated pipeline design was essential. Within Alyeska's team effort approach, Baker was assigned the task of mile-by-mile and, in some cases, foot-by-foot design of the pipeline. Engineers, in association with related professional fields, assimilate and utilize information to produce a design to meet the most rigid standards. Although 800 miles long, the pipeline requires only 6,000 acres of right-of-way, with the construction area about 50 square miles, which includes communication sites, the terminal facility at Valdez, and all 12 pump stations. About half of the line is buried conventionally, just as most pipelines are in the lower 48 states. This method is used, however, only in areas which will not be affected by heat from the oil. Site selected after it had been determined the soil would support the pipe in a thawed state. The pipe delivered to the burial sites in varying lengths of 40, 60, and 80 feet was strung, welded, machine-coated, and wrapped on the work pad prior to being lowered onto the bedding material in the ditch. Burial depths range from 7 to 16 feet. Approximately half of the line is built above ground, and Alyeska was faced with complex problems needing practical solutions. The above-ground design features a zigzag configuration to handle expansion and contraction caused by heat from the oil. This is just one section of a massive force of heavy equipment. Here, the world's largest land drill, with a 24-inch bit, burrows holes for the vertical support members 18 to 30 feet deep, and occasionally up to 50 feet. Huge side boom tractors transport the VSMs to their place on the line in a matter of minutes. As the unit is held in place, a sand-water slurry at high velocity is injected down between the VSM and the walls of the hole. This freezes to the permafrost and thereby stabilizes the members. Just one of 74,000. The pipe is supported between the VSMs by 37,000 horizontal beams of 8 different lengths, selected for anticipated movement due to heat, terrain, and seismic conditions. As we see here, the pipe is mounted on a shoe, which slides on a platform reel. As the line expands, the pipe can slide one way. As it contracts, it will withdraw the other way. 18 different shoes were developed as support, depending on ground slope, reaction to seismic movements, and critical regions such as the Denali Fault, one of the most sensitive locations the pipeline will cross.